Well, I'm really not planning on a lot today. I'm sure you'll be happy at that. I actually only have one example that I want you to watch. This is number 28 from your textbook on page 494, so you might want to have that open, or you have it here. In May of 2000, the Pew Research Foundation sampled 1,593 respondents and asked how they obtain news. The foundation reports that 33% now say they obtain news from the internet at least once a week. Pew reports a margin of error of plus or minus 3% for this result. It had generally been assumed, based on earlier polls, that only 25% got news from the internet. Does the Pew result provide strong evidence that the percentage has increased? Use the confidence interval to test an appropriate hypotheses and state your conclusion. Okay, just like we had done once before, we actually can use a confidence interval to do a hypotheses test. So the first thing I'm going to do, even though I am using a confidence interval, they're referring to, we want to test a hypothesis, so I have to first come up with a hypothesis. So for my null hypothesis, we're going to have p equals 0.25, because that was what was generally assumed before. So we have p equals 0.25, and I'm going to write that out in words, which would be to say that 25% of people get news from the internet. All right, so then we need to have our alternative hypotheses. So if we take a look at the wording, because remember how if you're going to tell if it's a one-sided or two-sided test, the question says, does the Pew result provide strong evidence that the percentage has increased? So that's my clue that it's not going to be a two-sided test. We want to see if it's increased, and now it is greater than 0.25. So this is going to be a one-sided test. So we can say the percentage has increased. So I have my hypotheses. Now before I can go on, I have to make sure that I am allowed to do this problem. And that means I have to check conditions, because the conditions have to be satisfied or else we can't go on with the process. So the first condition we're dealing with is random. And it doesn't tell us that it's a random sample specifically in the problem, but since it's a research foundation, I'm going to go with the idea that they have done a random sample. So we are going to assume Pew Research used a random sample. And this is a reputable research company. You can, I mean, maybe not as well known as Gallup, but definitely this would be something that they would do a random sample. If random, then respondents should be independent. Okay, for our next one, 1,593 was our sample size, and that's definitely less than 10%. And we want to think about our population. These are people who, we're looking at people who get their news from the internet. Well, so this would be 10% of people who read the news. I guess they wouldn't have to read the news. I suppose they could watch it on television. So maybe it would be better to say who get the news, whether it be in written form or through another media. So then we also need to check. Our sufficient size. Now this one, because it is, and this would be kind of tricky because we are treating it like a confidence interval, or I'm sorry, like a significance test. So for a significance test, we would do n times p naught. But we're asked to build an interval. So if we're going to build a confidence interval, then we have to use n times p hat, which would be 1,593 times 0.33, because that's what they found. The Pew Research found that that was the proportion who got their news from the internet, and you can calculate that. But clearly, a third of that is going to be greater than or equal to 10. Even if you said this, that would be fine. And n times q hat would be 1,593 times 0.67, and that's even larger. So we have no problem there. Again, the reason why I used NP hat and NQ hat is because I was asked to build a confidence interval. If I was just doing a significance test, so for a significance test, I would be using NP naught, which would be 1,593 times 0.25. And I would be using n times q naught, which would be 1,593 times 0.75. So it just really depends on which you're being asked to do. We're building a confidence interval, so I would use the correct with p hat and q hat. So my conditions are met. So I'm going to do a 1 proportion z interval. And again, get in the habit. After you check your conditions, your next step should be, what are you going to do? Well, we're going to do a 1 proportion z interval. I'm going to write the formula down. Okay, so there's my formula. All right, so going on from here, I'm going to go ahead and do a 95% confidence interval. So that way we'll know what our z-star amount is. Now, remember on your calculator, you can do stat test, and then you have to go down to find the correct test, which is a 1 proportion z interval. So it's this choice. Now you'll notice that you actually have to put the value in, and we don't have that. So you have to do a little backwards. We can do a little bit of backwards reasoning here. We do know that it was, our p hat value was 0.33. So let's take 0.33 times 1,593. So if we do that, okay, I got about 527. So I'm going to use that for the value. So now I can put these values in. So 527, and n is 1,593, and I'm going to do a 95% confidence level. And so here is my confidence interval I get. So we have between 0.308 and 0.354. So now I'm going to interpret that. I am 95% confident that the true proportion of people who get the news from the internet is between 0.308 and 0.354. Since the entire interval is above 0.25, this provides evidence that the proportion has increased. Now, unless I was specifically asked to use a confidence interval for this situation, I wouldn't do that. I would do the typical significance test. I would go on and calculate a p-value and then see how unusual that p-value was. But here we were specifically asked to use a confidence interval. However, in reading this again, it just dawned on me that it says to use the confidence interval, actually the one that they gave right here, because they reported a margin of error of plus or minus zero point 0.3. So we could have done this problem much easier, still with this null hypotheses and alternative hypotheses. But now if you see what I've marked in green, they came up with a p-hat value of 0.33. So if we take 0.33 plus or minus 0.03, which was our margin of error, we would have gotten between 0.3 and 0.36. This would have been our confidence interval. We wouldn't necessarily have our confidence level at this point. We could figure it out if we did a little bit of math calculations with some values, but we could have figured out what level of confidence it was. But I could have used the confidence interval that they gave me, which was from 0.3 to 0.36, and we could have said this was entirely above 0.25, so that would give evidence. So then that would have avoided that work, but that's okay because it was good practice anyway, to go through the process and making sure you check conditions. So that is it for today.